Hello students, the question is asking a point object is placed at a distance of 60 centimeter from a convex lens of focal length 30 centimeter. If a plane mirror were put perpendicular to the principal axis of the lens and a distance of 40 centimeter from it, now the final image would be formed at a distance of. So basically students, here we have find the final image. So now if I am talking about object, so here object is placed at a 60 centimeter. If I am talking about focal length, so focal length we have given that this is a 30 centimeter. So the students, we can say the object is placed 2f. What students? Object is placed at 2f. Now students, if I am talking about first image which is formed by a lens is at a distance of 6 centimeter, because of we know that if object is placed at 2f, so image is also be formed at 2f. That means first image is formed at a 60 centimeter. So we can say this is our first image, which is I1. Now if I am talking about second image, so second image is formed by a mirror. So for this mirror, I1 behave like a virtual object at a distance of 20 centimeter. Because of this is 40, this is 60, so the remaining will be 20. So we can say by a plane mirror the image will be at a same distance of object. That means we can say I2 image is formed at this distance, which is 20 centimeter from plane mirror. Now this I2, if I am talking about this I2, so this I2 image is behave like a object after reflection for a lens. So we can say if I am talking about U, which is the distance of object from lens, it is 40, so this one is 20, so we can say this one is 20 centimeter, and the value of for final image, we can say for final image the value of U is equals to minus 20, focal length is equals to given as 30 centimeter. So if I am talking about final image, so for final image I am saying that by lens formula 1 upon V minus 1 upon U is equals to 1 upon F. So 1 upon V we have find minus U, the value of U is 20, so this one is plus 20, 1 by 20, and focal length is 130. If we solve this equation, so V is comes minus of 60 centimeter. What sense? Minus of 60 centimeter. So that means the final image is at this distance, which is I3, at a distance of 60 centimeter. Now if I am talking about distance from the plane mirror, so this is our 40 centimeter, so we can say the remaining distance is 20 centimeter, and the image is formed virtual. The image is formed virtual. So the answer which is correct is option number 3, which is 20 centimeter from the plane mirror. It would be a virtual image. What sense? Virtual image, and from plane mirror the distance is 20 centimeter. So the answer is option number 3. Thank you. Hello students, the question is asking a particle of mass small m is projected with a velocity v is equals to kve. Here k is less than 1 from a surface of the earth and v is the escape velocity. Now maximum height above the surface reached by the particle is. So basically students, we have find the maximum height from the surface of the earth. Now students, if I am talking about the situation, so situation we have given that there is a earth, let the radius is r, initially particle at the surface, and it gives a velocity which is v is equals to kve, and ve is a escape velocity, and the value of escape velocity is 2 gm by r. Now at a maximum height which is h, the final velocity of the particle will be 0. If I am talking about the energy conservation here, so we can say this is our initial condition and this one is our final condition. So between initial and final condition, by energy conservation, we can say U initial plus K initial is equals to U final plus K final. Now U initial is what? This is minus of Gm small m by capital R plus initial kinetic energy is half m v square. V square is k square v square. So we can say this is k square and ve square. That means this is 2g m by R. Now 2 we have cancelled, is equals to final kinetic energy should be 0. So this one is 0 and final potential energy comes minus of g m upon R plus h. What sense? R plus h. Now students, here g this one is not m, this one is gm by 2. So this is mgm and this is gmm are cancelled. We have solved that equation, so we can say the remaining is minus 1 by R plus k square by R is equals to minus of 1 upon R plus h. So this is our equation. Now we have solved that equation and find the value of h, which is the maximum height. What sense? Which is the maximum height. So here we have solved that. So now I am saying that this is our R and this one is minus. So minus we have taken common. So this is 1 minus k square and it is minus of 1 upon R plus h. Minus minus we have cancelled. We have solved that. So this one is R upon 1 minus k square is equals to R plus h. Now we have solved that. So after solving that, the value of h is comes h is equals to R k square upon 1 minus k square. So this is the value of h, which is maximum height from the surface of the earth. Now if I am talking about option which is correct, so here the answer which is correct is option number 3, which is R k square upon 1 minus k square. It correct answer for this question. Thank you. Hello students, the question is asking a series LCR circuit containing 5 Henry inductance, 80 microfarad capacitor and 40 ohm resistor is connected to 230 volt variable frequency AC source. Now the angular frequency of the source at which power transfer to the circuit is half. What is it? Power, if I am talking about power transfer to the circuit is half of the power of resonant angular frequency. Resonant angular frequency. Power at the resonant angular frequency are likely to be. So first of all we have find the value of omega. So this is given, which is power is equals to half of power in resonant circuit. So here we have given LCR circuit. So this is L, C and R circuit and there is a AC source having a RMS which is V is equals to 230 volt. 230 volt. Now students, if I am talking about power, so P, which is power, is given as V square by Z, which is impedance cos phi. This is equation 1. And if I am talking about power in resonant circuit, power in resonance. So in resonance cos phi is equals to 1. So this is PR is equals to V square by R. This is equation number 2. Because of Z is behave like a resistance. Now we have equation 1, 2 and this is 3. So now from 1, 2 we have put the value of P and PR in equation 3. So here we have roughed that portion and we have find the value of this by calculating equation 1, 2 and 3. So from 1, 2 and 3 what we have right here, the value of P is V square by Z cos phi is equals to 1 by 2 and PR is V square by R. V square by R. So V square we have cancelled. That means the cos phi is equals to Z upon 2R. This is comes. And we know that students, power factor cos phi is equals to R by Z. So here students we can say this is R by Z is equals to Z upon 2R square. So I am saying that here the equation which is come is 2r square is equals to z square, and the value of z square is r square plus xc minus xl whole square. Now this comes as what? This is r square is equals to xc minus xl whole square. Now this equation, so we can say this one is xc minus xl plus minus r. So this equation comes. Now we have put the value of xc and xl. So here this equation is comes and we have solved this equation by putting the value of xl and xc. xl is omega L and xc is 1 upon omega c. So the value of xc is 1 upon omega c minus of this is omega L is equals to plus minus r. Now c is given as capacitance is given as 80 microfarad. So this is 1 upon omega multiplied by 80 and micro is 10 to the power 6 minus of omega multiplied by L is given as 5 and this is plus minus 40. So here students we have two values we have find of omega. Now we have put all the values option 1, option 2, option 3 and option 4. So when we have put so the correct answer which is satisfied LHS and RHS is equation number 2. When we have put the value of omega is equals to 46, first of all we have take positive 40 and second one is negative 40. So if we put 46, so it is satisfied. That means the answer is option number 2. Thank you. Hello students, the question is asking, for the given circuit, the input digital signals are applied at the terminal A, B and C. What will be the output at the terminal Y? What we have find? The output at the terminal of Y. Now students, if I am talking about a circuit we have given, so this is our circuit. So if I am talking about Boolean expression for this circuit, so this is A and this is B and this is our AND gate. What students? This is our AND gate. That means the output of this is A dot B. Similarly, if I am talking about B and C, so this is our what? This is NAND gate. What's it? This is our NAND gate and or NOR and or. So we can say this one is B dot C bar. What's it? B dot C bar. And this inputs are comes at OR gate. This is our OR gate. That means the value of Y is comes. This one is A dot B plus B dot C bar. So this is our Boolean expression for this circuit. Now students, here for find the answer we have put the values. Here we have given the signals. In first pulse A is 0, B is 0, C is 1. For second it is 1, 0 and 1. So we have checked only two options here. So we have say that y is equals to A dot B plus B dot C bar. A dot B plus B dot C bar. So this is our Boolean expression for this circuit. Now we have put the values of A and B and C. So for first A is 0, B is 0 and C is 1. So we can say for first pulse output is Y is equals to A is 0, B is 0. That means 0 dot 0 plus B is 0 and C is 1. That means 0 dot 1 bar. So I am saying that this is 0 plus 0 bar. That means this is 1. That means the resultant will be 1. What sense? Output will be 1. So now if I am talking about option, so here we have clearly see that option 1 and 2 are wrong because of it has 0 and 0. That means this option will be wrong. Now we have checked for third and fourth. So for that we have checked for second pulse. So second pulse will be A is 1, B is 0 and C is 1. So now I am saying that for second pulse Y is equals to A dot B. A is what? This is 0. A is what? 1. This is 1 multiply B is 0 plus B is 0 and C is 1. So this is dot 1 and this is bar. So this one is 0 plus 0.10 and bar is 1. So this one is again 1. So for second pulse it is 1. First pulse is 1. So the answer which is clearly see that option number 3, because of for option number 4 for second pulse the output will be 0 but it is comes 1. So the answer which is correct is option number 3 is correct answer for this question. Thank you. Hello students, the question is a ball of mass 0.15 kg is dropped from a height 10 meter, strike the ground and rebound to the same height. Now the magnitude of impulse imparted to the ball is, and the value of G is given. Now students, if I am talking about the situation, so here the situation is given, there is a ground. Now there is a ball is dropped from some height h and the value of h is 10 meter. Now when it is strike to the ground, it has the velocity v is equals to under root of 2gh. After the strike, ball has same velocity which is v is equals to under root 2gh because of it reach at the same height. What students? It reach at the same height, that means after rebound it has same speed which is under root 2gh. If I am talking about impulse, so we know that students, impulse is equals to change in momentum which is P final minus P initial. Final momentum is mv and initial momentum is minus of mv with the direction, that means it comes will be 2mv. Now we have put, so this is 2 multiply m, mass will be 0.15 and velocity is under root of 2g. The value of g is 10, h is also be 10. When we have solved this equation, it comes I is approximately comes, this is 4.2 kg meter per second. So this is our impulse which is 4.2 kg meter per second. So the answer is option number 1 which is 4.2 kg meter per second. Thank you.